All right, well, thank you for joining today's webinar on this very exciting topic of ultra-low latency video. We are very passionate about this topic, and we hope that this webinar will provide some insights to not only what this technology is, but about this game-changing application that are going to be created, and especially what problems and challenges this technology will solve. What good is a technology if it doesn't create value? What good is a technology if it doesn't solve problems? And we at Saliton Systems strongly believe that this ultra-low latency technology is going to provide tremendous benefits to society. And that's why we're very, very passionate about this topic. And we have with us today our mobile video transmission technology specialist, Aki Abe, who will walk us through about the technology and use cases. Hello, Aki.
Hi, good morning, everyone. Thank you for joining with us and hope you enjoy today's webinar. Thank you.
Yes, thank you. And, to the audience, Aki and myself, we're both in California. We're still in lockdown, so we're doing this webinar from our home studios. So, let's get started. Here's the agenda today, where we will talk about ultra-low latency technology. We'll talk about the different applications, and we'll show you a demo. And then we'll open up for questions. And if you have any questions, please post your questions in the QA chat box. I think it's down there somewhere. So please post them in the QA chat box. But first, I have a question for you. I'd like to ask the audience a question. So today when we talk about latency, people think, 2 seconds, maybe 5 seconds, or depending on the application, maybe it's 1 second, or maybe it's under 1 second. This is all good depending on that particular application. For broadcasting, for example, 2 seconds, 3 seconds is acceptable. For one directional virtual reality, 5 seconds is okay. Maybe since it's one directional, VR, maybe 20 seconds is okay. For drones, if you're controlling the drone and shooting live video, 1 second, 2 seconds is acceptable. By the way, our other mobile encoder, not this ultra low latency one we're talking about today, but our other encoder, it's called Zao-SH, gives you anywhere from 240 milliseconds to 2 seconds latency, which is actually really, really good. But even a sub 1 second latency is not good enough for applications that require near real-time video. And the question to the audience is, what if latency was dramatically improved? Let's say under 100 milliseconds, what new applications, what new use cases will become possible? What new business models will become possible? And that is what this webinar is about today. But first, a quick background on Saliton Systems. We are a Japanese video technology pioneer with US offices on the West Coast. And here's our core technology. We have been developing video codec for a very long time. And we believe that we are a pioneer and thought leader in this field, where we build unique algorithms on top of the H.265 codec to enable features that are important to providing quality video streaming, especially in areas where the network is unstable. Let's think about that for a second. As a video professional, you are in the field shooting live video. Maybe it's point-to-point solution, maybe you're streaming to the cloud. Either way, someone at the other end is receiving and viewing your live video transmission. And if you're shooting video live, you are capturing the moment, and that live moment is never gonna come back, which means you need very reliable technology that makes sure you capture it, encode it. And here's the challenging part, transmitting that live video when you may not have reliable network connection. Let's just say you're covering news coverage at a protest or any event really, where thousands of other people are streaming video from their cell phones on the same network. There's a very good chance that you will not have reliable network. Your video stream is going to be choppy or even disconnected. Then what are you going to do? And we've all experienced that. And we all know that it's the most frustrating experience, especially if your livelihood depends on it. Or let's just say you're shooting live coverage from a drone up in the mountains. You're streaming through a modem with very little bandwidth. And this is where you need reliable technology. This is where you need multi-link bonding technology that aggregates multiple network carriers, in our case, up to 4, And our unique algorithm analyzes the network situation and controls the transmission settings automatically. And, Aki's going to explain about this in a second. But, and then in addition, our video transmission IP provides load balancing, packet sorting, error correction, encryption, authentication, intelligent encoding. All that is optimized for commercial 4G and 5G networks to deliver smooth, stable video in the most challenging network areas. This is our current product, Zao-SH. It's part of our smart Telecaster solution, where we have deployed over 7,000 licenses for broadcasting, public safety, surveillance, drones, and other applications. It is being used by video professionals around the world and for news reporting of all sorts, like this reporter. Actually, that's Aki demoing our H.265 encoder to a point-to-point receiver. He looks like a real, news reporter. And by the way, we have the YouTube channel, this one, and so please check it out. There's videos on all kinds of topics of interest for video professionals. And back to today's webinar topic, we just released the world's first ultra-low latency encoder built on the H.265 codec and our unique video processing algorithm, where we achieved a dramatic decrease in latency. Our latency specs are 35 milliseconds LAN, 65 milliseconds 4G LTE. That's right, 35 milliseconds, 65 milliseconds. And here, I would like to ask Aki to explain about the video processing technology that enables live video streaming. Go ahead, Aki.
Okay, let me turn on my video. Okay, let me explain the video processing and transmission. So we have our program that's a real-time auto speed control based on the waterway model. So the reason we call this waterway is because the video processing depends on the contents you deliver. So it's changing all the time. And also we're using mobile network, which is like you see this diagram, when you started on the vertical side, you have a higher bit rate. That's good enough for deliver HD quality video audio. And then, but for many reasons, it's dropping from the very high bit rate to the lower bit rate, and eventually to the middle. As you see, the bottom line here, if it go lower than that, so you cannot, compress the video and deliver because it's too narrow. But based on this, we have our own algorithm and to analyze which individual mobile network connected, whether it's a good condition or not. So we sorted out the package, and then based on this, and we also take care of in every bit rate, whether it's low or high, we smooth it out, transfer the video package and deliver to the decode side. So we're trying to make that video as smooth as possible. So this adaptive, that means you using mobile network to transmit your video audio always is fluctuating. So we are trying to analyze it and do the optimization for each bit rate as smooth as possible. And again, let's talk about when you go to the remote area and transfer the video audio. And of course, in the remote area, each modem probably you don't expect that is received a higher bit rate for each of them. So we aggregate, which is bond together. So each modem maybe is less than 1 meg, then you bond it together to make a sticker. Totally, you can send more bit rate over the network. And this could be the different type of the carrier. So in US, AT&T, Verizon, T-Mobile, you also can aggregate them together, and that's why we call this multi-link technology and bundle with network interface. So this is the basic of our RASCO, and this is a regular we're using the Zao-SH, but the ultra latency we even have a better the processing on that. Okay, we can move to the next explanation.
Thank you, Aki. And now can you explain about our next generation video processing technology that enables ultra low latency?
Okay, So I just mentioned that the RASCO-1, this is our current technology. So basically it's a sequentially from the left to the right. You can see on the video side is a shooting, well, that's a, capture the video, and then we encode it, make it a package, so encoding, right? And then go to the middle, which is mean you sending from the field over the internet and to the receiver side and decode it. And then we synchronize with audio and video. Then finally, we display it to the display monitor or SDI output. So in this sequentially, we do this in RASCO. It's a sub millisecond, 1 second. So it can be half second. But now we have more needs from the market. We want to do this as quick as possible. So our developer come up with RASCO2. What it does is we just do this each section. Each section, we don't wait until that section is over, but we already pass on to the next section. So it's a parallel processing. So by that result, actually this graph, the RASCO1 is very long. It's 1 second in this length, and we chop it down and put it in like a parallel processing. And as a result, you will see it's a 40 milliseconds. This is actually, it's a true benchmark graph. We just took it out. So, by this RASCO2, we can shorten it to the less than, 40 milliseconds. So this is a parallel processing of our new RASCO2 technology. Okay. And let's take a look. There's a very simple how we apply that to the, we just want you to see the comparison of regular transmission and with ultra low latency transmission. So please play the video. Thank you. Connect this high-speed camera with SDI cable and put the two different type of 4G mobile network together. And we are going to do the normal transmission. As you see on the monitor, is 1 second delay. Now this is transmit with ultra low latency, which is less than 65 milliseconds. Okay. Yeah, so this is very fast, and best effort on the LAN wire transmission is a 35 millisecond latency. So these are, by the way, we can available put into the SDI output, especially for the TV station broadcaster. This is available as well. So, for this technology, what we can apply to is just like imagine that, usually you see on the news program, it's a debating. So there was the press A with the press B person that all talk to the TV station, the presenter. But it's just one way to the TV station. Usually this take about 3 seconds to 5 seconds. But if you're using this ultra low latency, even though it's a mobile, probably it's a 65 milliseconds for each, but still, from the press A to the TV station and press B also send it to TV station. But this A and B person, they can talk to each other online in the live program. So because 35 or 65 and 65 is less than 1 second. So they can, with this very short latency, they can do the debate program in the live. And also it's now today, I think the TV station, mostly they do this in the studio. So studio is a very good fiber optics. So that's available. But with this technology, even though it's outdoor and with a mobile network, we can do the debate program. It's pretty much amazing. Next page, we would like to, yeah. So by doing this, what we need for the receiver side, this is a RASCO2. So it's come up with the very simple HP computer, and it's i7, it's i7 CPU. And best effort for the LAN network is 35 milliseconds. And also this is encrypted bonded with a 4G SIM card or the LAN port. Of course, the 5G network is available. And on the receiver side, right now we have a one-channel receiver available as audio video is available. And in the future, we plan to do this also to the 4-channel. And spec-wise, it's I say HP G4, it's like the workstation type of computer, and with a graphic board, NVIDIA RTX 4000, and plus, and as a picture you see, this is a Blackmagic Video decoding card Pro 8K. So with this one, eventually, when our software developed is available, we can output 4-channel to the SDI. And this is special for the TV broadcaster. They can benefit. So this is a point-to-point. You know, and as usual, we need a fixed IP for receiving the video from the outfield. And we use this UDP. And yeah, current version is the same as Zao-SH. Okay, they're very simple, but importantly, the resolution at this moment is HD quality, so it's a 1080p with approximately output is 30 frames per second. Even your camera is 1080p 60 frames. At this moment, we will output with 30 frames per second. And that's the maximum resolution we can put. Okay.
Thank you, Aki. That was a great video, by the way. And as a reminder, this video is going through Zoom, and there's additional latency over Zoom, and you know, whatever latency there's on your network. But yes, it's really amazing, this you know, extremely low latency. And you know, you may think it's a subtle difference between 1 second, you know, 1,000 milliseconds and 65 milliseconds, but actually it makes a world of difference in applications that require near real-time latency. And now, you know, I posed this question in the beginning of this webinar: if ultra low latency was possible, what new possibilities would emerge? And these are Saliton's answers. The foundation, what you see at the bottom, this is the video processing algorithm that Aki just explained. It's our technology foundation. And on top of that foundation, all kinds of possibilities will emerge. For example, streaming AR, VR, interactive AR, VR, real-time telehealth, telemedicine, real-time surveillance like SWAT teams that needs precision timing, remote surgery. You know, yes, it sounds a bit crazy, but it's going to become a reality where a world-renowned doctor who is maybe hundreds of miles away might perform surgery on me. So this is going to become a reality. And then a remote studio, remote live, streaming live in very, very low latency. And then there's going to be new 5G applications, because communication carriers are looking for those new use cases, new customer experiences using very low latency over 5G. What's already a reality today is autonomous cars, self-driving vehicles. And what's happening on the back end is someone remotely monitoring and ready to take over the control of the car if the driver needs assistance. Or maybe when the driver gets in an accident, you know, we hope not, but just in case, right? Or maybe there's obstacles on the road and the driver needs safety assistance. And Soliton Systems has been a thought leader in this space, and we have been working very closely with automotive and teleoperation companies. So Aki, on this note, could you explain some of the proof of concepts we are doing in this space? Aki, you want to go ahead and explain about the automotive related, autonomous related POCs?
Okay, sorry about that. I forgot to unmute my mic. So let's take a look at this picture. So we have this car with our encoder, and that encoder attached to the camera. So we can send over this video audio through the 4G or 5G networks through the internet. And on the right-hand side, it's on the virtual cockpit. What it does is, I forgot to mention that in the vehicle side, not just audio video, you also can have the communication data attached with our IP package and send it over to the receiver side. And video is one way, audio is the two ways. But this is data transportation also is two way. So which is mean we can send every sensor, for example, shock or the turning wheel or axle or brake. Those information can be sent to the virtual cockpit. And of course, there's a person on this cockpit bucket seat. He can change the wheel, accelerate, and do the brake. That information also sent back to the edge side and the vehicle side. So this remote driving cases can be done. As now today, we already done this. So with a 4G network. So that's available for now. And for this application, not just for the regular vehicle, we also do the construction machine. So construction machine, you can go into the construction area, and the people in the remote side, maybe a nice air-conditioned room, you can remote driving this one. So that can be extend your ability to send in, to use your human resource as much as possible. And also for the very, we can show this later. Also, if you have a drone, and if that drone is have enough payload, you can put our encoder camera onto the drone. And also, again, that can send the picture from the air, picture meaning a video from the air and to the remote control side. And also, you can use this serial port function, so you can remote control the camera, whether it to pan, to left to right, or you can zoom the camera, controlled by the ground. So on the ground, the controller not just only can able to drive this drone, but also the camera, you can also move it. We can show this later, the picture. Okay, the next page, please. So on this one, we also do another proof of concept. Actually, we do this with the Japanese university as a partner. It's already ongoing, and it tests on the street, as you see here. On the middle side, you can see these boxes. Actually, we put our encoder inside of there, and we bring those video, the camera video, up to our cloud. So on the right-hand side, you can see there's a different type of angle of the camera. So you can I can see the three screen, and on the right-hand side, the bottom side, there's a talk about the you can see each setting on the encoder side. So that's video, audio, you can see, and also you can see and change the bitrate or network setting on the right-hand side. So this is the application we are using now today. Okay, next page, please. And this is also another application. Actually, we have been done this in the early of this year in the Tokyo exhibition. We do with a major carrier. It's called NTT Docomo. It's just like AT&T in the US. And also the Komatsu is like a construction machine, and yeah, just like a US in here, Caterpillar. We do this. We put the multiple camera on the construction machine and show on the left-hand side, this is a 5-screen. So this person can drive remotely this construction machine and 280 kilo away. It's about 170 or 160 mile away. And I want to also mention that in this 5-screen, as you see on the left-hand side, you could see 2 red boxes. There's a human being there. Actually, we deliver this audio, I'm sorry, we deliver this video and to their system. So they bring this system output to their AI profile. So this is an AI program that application is like if this construction machine, there's people surrounded and too close, and they give this warning. As you see, it's a red spot, red square line. So this machine cannot be moved, cannot be operated unless this two worker, they can walk far away and that become the yellow boxes, and eventually more far, it's become the green boxes. Then eventually you can move this construction machine. This is one of the applications. You're not just using the audio video delivered to the monitor, and also you can send it to your own, program that the profile, like AI program. So you can conjunction with using this technology together. Okay. And let's take a look at another video here. And it's actually we're using the RASCO technology. Even this is not the RASCO 2 yet. We have been doing this for the 2 or 3 years already. So yeah, just take a look simply. Let's take a look at this simple remote driving. Video and communication signal has been transmitted with 4G network. You will see this bucket C is vibrating because that's synchronized with the communication signal. The car is slowed down from 25 miles to about 10 miles. Approaching to curve again, very smooth. Now at the vehicle side, wheel was driven by remote driver, very smooth, speed is slowing down and approaching to the curve again. So this is the real cases we're using very low latency video transmission. Okay,
Right.
that's about my part.
Great, thank you, Aki. And I wish we could have the audience experience this remote driving experience, but that's not possible over Zoom. So, but we hope you get the picture. And then now we'd like to show you another video. I will use this control pad to remotely operate. Just like this. It's moving very precisely. Nice. Very nice. This remote control is connected to the receiver computer. And now let me operate the camera. And I can control the camera as well. Beautiful. So you see me operating this and probably wondering what's the technology behind it. And it's because of the ultra-low latency video transmission technology. What's being captured here and what's being displayed here, the time difference between the two. The more delay and latency there is, the harder it is to control and operate. Thank you. So, that's just one of the use cases using ultra-low latency video technology. And then to the audience on this webinar who are technology developers or teleoperation companies who we hope we got your creative thinking and new ideas going. And please reach out to us. Please call us. We can help you with architecting your new solution, whether it's a remotely operating construction equipment or real-time drone video streaming for surveillance or autonomous vehicle remote controlling. Please call us and let us help you realize that new application. And then before we go to Q&A, I'd like to mention that we have a ultra-low latency POC kit that we have for sale. It includes the encoder, camera, monitor, receiving hardware. So it's turnkey. You can integrate this kit into your test environment and test for yourself, see for yourself this very low latency that this technology provides. So with that, I would like to open it up for questions. Let's see. All right, let's see what kind of questions we have here. Hold on one second. Okay, Aki. Oh, Aki, here's this one's for you.
Okay.
The question is, good question. How much latency can be expected over the 4G LTE?
Okay, 4G LTE, as we mentioned, also you see on the driving cases, the regularly will be around 65 milliseconds. No, sometimes it's more than that or maybe shorter than that. So average for the mobile network with 4G is about 65 milliseconds.
Got it. Thank you. And then, okay, here's another question. Oh, Aki, this one's for you too. What options are available for outputting the video?
Oh, okay. So Tommy just mentioned that we offer a POC kit, and that one with the two solutions. One is a display port. So that display port can connect to the high-speed monitor, not a HDMI port, because HDMI port is a little bit slower. So the quicker signal can do is the display port monitor. That's one. And the other one, now today, we also can output to the Blackmagic SDI video card. It's a Decklink Pro 8K. So that 8K is outputting SDI. Of course, after posting the SDI output, the signal, you also can convert it to the HDMI video port. But that will sacrifice a little bit latency on that. Again, so summarize the answer is one is a display port video output and also SDI output.
Got it. Thank you. All right, let's see. Questions are coming in. Thank you. I'm looking at them. Oh, here's a good question. And then Aki, I'll take this one and then please chime in. The question is, isn't 5G good enough for these new teleoperation use cases? Thank you. It's a good question. And actually, we get this question a lot. And our answer is no. 5G itself is not going to solve the latency problem. Actually, we have a slide on this. Let's see if we can pull up this slide. Yes, this one, yeah. So, earlier Aki was talking about how we decrease latency by this parallel processing, but actually the 5G only improves latency in the transfer portion. So when in the other layers, encoding, decoding, 5G does not improve latency there. So our answer is, yes, 5G will improve latency, but it's not going to solve the full latency problem, which is why you need this ultra low latency video technology. Aki, anything you'd like to add to that?
Oh, no, I think pretty much you answered all the question. Yeah, again, there's a parallel processing is, you see this, each section is chopped. On the RASCO one is sequentially is the process. And then the RASCO 2 is, we don't wait until the one process is ended. Very soon, in certain of our algorithm, we will pass on to the next section and so on and so on. That's why I can shorten the latency. Oh, by the way, it's very good question. A lot of people asking us that, when 5G came out and you don't need that our technology, yes or no, it's not true. It will speed it up in the middle. As you see this transfer 100 milliseconds, this portion probably can shorten to, very short, like a 20 or less than that. But still, you need another processing from the video capturing, the IP delivering, and IP sorting, overflow, and display. Those technologies still needed to be done quickly. So still, yes, we are trying very hard to make it stable and shorten latency as possible, and along with the 5G network.
Great, thank you. Okay, here's another question. This one's for you, Aki. The question is, which are the protocols supported for remote data transmission?
Protocol-wise, we don't limit it any kind of protocol. As long as, at this moment, we're using the serial tunnel technology. So that's kind of communicate with, just like, you with the device, with the serial port. And so it's a virtual serial port over the network. So as long as on the decoded side, we transfer the number for you, and you have your own program to detect that what how do you want to sort out that the number for your particular purpose. So as long as that can be sent through the serial port, so we can deliver it, and you can deliver it and analyze it and use it for your operation. Yeah.
Great, thank you. Here's another question. I think we have time for maybe a few more questions. Aki, this one's for you. The question is, I'd like to see if audio and video can embedded be transferred and delivered by the encoder and server.
Oh, yes, we didn't prepare this webinar. Sorry about that. I think this sees this question. Thank you very much. But we would like to arrange another meeting, especially focused for you. And I have to think, how do I deliver this clear audio for you to see? That's very clear. So yes, please wait for us. Probably within a week or 2 weeks, I can prepare another demo environment that can show it to you. Thank you.
Okay, thank you, Aki. Maybe it's a related question, but another question is the IFB considered in this new version as well?
It's the same technology, but because we mentioned that the protocol from RASCO 1 to RASCO 2, the parallel processing is different. However, on the audio video synchronization part, it should be same algorithm. So it's hard to answer. It's not exactly same, but overall the base of the technology synchronization part is the same, but the process order wise is different.
Great, thank you. We have a few more questions here. Aki, this one's for you too.
Yes.
What's the highest supported resolution?
Oh, at this moment, it's HD quality, so that would be full HD resolution, and output will be 1080p 30 frames per second. And even though your camera will be 1080p the 60 frames per second, but we output in the 30 frames per second at this moment.
Got it. Thank you. All right. So two more questions. The first one is where does this ultra low latency fit in the autonomous vehicle architecture? Actually, we have a slide on this. If we can pull that up, it's our. Let's see here. Yeah, this one. So where we fit in really is obviously in transmitting, very, very low latency video over the network. But what's important is that, all the edge folks today, as AI moved from the cloud to these edge networks, these edge folks are adding intelligence to, audio and video. So that's being transmitted over the cloud into the other side, into a data center, whether it's a, private data center or hybrid model or public, of course, where, image recognition, facial recognition, that's being done. And then that's being pushed to the end user, in this case, the driver, to create, very new experiences for the driver. So it's a very exciting ecosystem, if you will, where transmitting, very, very low latency video adds value to the end user. So there's a lot happening here, and then we're working with the edge devices, of course, and the edge operators, the edge, the storage folks, to build this network out. So it's a very, very interesting scheme. And then last question, Aki, this one's for you. I understand the video transmission portion, but could you describe the serial control part?
Oh, well, serial port in our regular, today's the receiver software, there's a serial port to set it up, what's the speed of the baud rate and what's the parity bit. It's very simple, just like you set it up for the terminal port. So we have a 2-port. You can put two like a converter from the serial to the USB port converter, put it into our encoder, and then you just set up the speed port and the stop, the bit rate, and very simple. Yeah.
Great, thank you. Actually, we have one more question that just came in, and then
Yeah.
the question is, how do we connect with you guys? What's your website? And yes, we can maybe pull up that screen with our website and our contact info. Yep. Yes, so it's, yeah, here's our website, here's our contact info, it's solitonsys.com. You know, all the information is there, but please, you know, reach out to us, you know, email us, and we're very happy to, you know, connect. And like I was mentioning earlier, to address, you know, your requirements, not only for ultra low latency, but for, you know, video streaming in general. And we have, you know, encoder models, we have different receiver models. So we can help you, we can assist you with your live streaming needs. So I think with that, I want to say thank you everyone for joining this webinar today. And, you know, thank you, Aki, for your expertise, and we'll be in touch. Thank you, everyone. Yes,
nice to see you again, and please contact us. We can set up the demo for you, and especially thank you for spending the time with us today. Bye-bye.
All right, thank you. Take care. Bye-bye.